Greetings and welcome, friends. We were solving the compoundest of inequalities. That's when, it's like you have an inequality, but then there's like two inequalities, and then they're together. Yeah, it's amazing. So let's take a look. It says, write a compound inequality that is represented by the graph. So this part of it looks to be everything that is less than -7. Does it include -7? I think so. That looks like a solid dot, so we'll call that less than or equal. This side of it appears to be everything that's greater than or equal to -4. But I want to point out that there is no such point that is both bigger than -4 and less than -7 at the same time, right? Like -8 would be true for this, but it would fail for that. So the only way both of these could be together is if I threw an or between them, because nothing will be true for both of them at the same time. It will be one or the other. Yes. And we talked about yesterday that typically your OR graphs are shaded away from one another, whereas AND graphs, I believe our word was together. The word of the day yesterday was together. And then we all, high-fived at the end of class. Remember that? That was amazing. That's just, like, Mr. Waddy's fan fiction of math classes. Yeah, good stuff. Let me go back. I think that's it, right? Yeah, they just wanted me to write the inequality that represented the graph. Yeah. That was it. All right, here we go. Here's some words, and we want to write them into math. So it says a number n, okay, is less than or equal boop, 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 to -7, or greater than 12. So that means the same n number is greater than 12. All right, so there's my compound inequality that represents both of those things. And let's draw a number line. 0, -7 is going to be closer, a shorter distance to 0 than something like 12 would be. So I'll throw 12 over here, maybe. I don't know. It doesn't have to be to scale. I'm not looking for engineering, architectural drawings, stuff like that. So less than or equal to -7, that'll be a closed circle. And less than would be to the left then. And greater than 12, that's an open circle, and greater than is to the right. Right? So that's the way we would do. That's how we'd do. Right? So stuff like this will be on the test Monday. All right, here's the fun ones. I think I chose some of the better ones to look at, some of the more challenging ones. So the way we described this the other day was, wait a minute, this is weird. There's like two inequalities. And we said, well, pretend that this didn't exist for a minute. Guys, your imagination is so good, you're able to mentally conform reality to your will. Your imagination just made that disappear. That's amazing, you guys. So if I wanted to solve for r, what would I do to both sides? Divide by -3. And the only thing I'm going to do different is, there's 3 sides now. We'll divide all of them by -3. All right? So that's all you do different. It ain't nothing scary. And 24 divided by -3 is -8. These cancel out. I just get r. And negative divided by negative is +3. And in dividing by a negative, we said the magic word. Divide a negative or multiply a negative, right? And that means we've got to flip those signs. And this is written from least to greatest. That's convenient for us. We like to write our answers that way. And notice that in the inequality, algebraically, the r is between those numbers. And graphically, my shaded region will be between those numbers. Okay? So that's kind of a way you could think about it. So here's -8, 0, I don't know, we'll call it here, and 3 is not going to be quite as far as -8 was, but it'll be to the right of 0. And to graph this, this will be an open circle at the -8, a closed circle at the 3. That's interesting. Yeah, you can have little hybrid solutions like that. And it'll be shaded with the variable in between. Because and is together. Wow, that was a beautiful song. All right, wow. There you go. Okay, and then for ones where you have an or, I would suspect these are going to be shaded away. And to solve an or inequality, you just kind of like solve this side and then you solve that side. You deal with them separate. So to get dubs by itself, how do I deal with that +3? Yeah, subtract 3, both sides. Both sides. -17, that became more negative, notice, is greater than W. But we want to write this with our variable over here, so I'm going to call this W is less than -17 and flip it. And let's see, for this inequality, to undo that multiply by 3, I would divide both sides by 3. Do I have to flip the sign here? No, because I'm dividing by a positive, right? I don't mind that this is a -27 at all. And that's -9. And this or is here, so let's throw a little or there. And I believe this is going to be our answer. But let's graph this and just kind of see, just to verify. So I'd have like 0, like -9 would be like here, -17 would be not quite twice as far. And open circle shaded to the left. And closed circle shaded to the right. Wow. Lovely. I think I picked one more problem for us to look at, but who knows? I can never really trust my past self. Yeah, look at that one. No, I think I picked 2 more. I was wrong. So this one's got the or to solve. Yeah, this is just going to have some distributing over here. Whoop, 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 whoop. And, well, I've got this color selected. We'll distribute over there as well. Green, but I've got such consistent color patterns for my whole video series. But if you are a fan of green, go check out Amity Math on YouTube. He could show you how to do some math with some better color selection than mine. So guys, to get the B by itself, this was a +14. A super classic mistake here, by the way, is that people think this minus sign applies to the 14, and then they would try to add 14 to both sides. No go. That minus sign is attached to the 7B. So beware. So 35 minus 14, was that like 21? Sounds like. Is less than -7B. And how do I get rid of that -7? Do I like add it to both sides? No. Because that's not subtract 7, that's -7 times B. I divide. And so I'll have -3. I've got a B, and you must flip it, right? Because we've got this like divide by a negative. You must flip it. And then we'll put the variable on the other side, because why would you do that? So once again, you must flip it. There we go. So B is less than -3 for this inequality. Let's check out this distribution over here. 1/3 of 15. Another way you could ask that is, what is 15 divided by 3? And yes, you are correct. That's 5, and with a B attached to it. And 1/3 of -12 is going to be negative. Negative what? I like it. Greater than or equal to 21. Let's see. Whew. Yeah, what do I do? Not just a 21. Both sides. Yep. Divide by 5. And Bravo is greater than or equal to 5. Okay. So my combined solution, tell you what, I'll even write this with a sloppy. Look at that. That's amazing. Amazing. I feel like I might have one more problem. But yeah, so it's not that bad. It's just kind of all of our skills combined. Aha, here we go. Now this one seems suspicious to me. It says if possible. So I'm intrigued. Here, I'll cruise through this one. Ready? So add 1, add 1. So even if you guys just want to follow along and just kind of like take in the big picture, not a bad idea. Div 2, div 2. Oh man, slowing me down. M is greater than or equal to 3. And then over here, div 5, div 5. And man, come on, click that yellow. M is greater than negative 5. Now, I'm hesitant for a moment here, right? And Ethan's getting a text about this as well. Someone's like, Ethan, I don't think that problem's going to be a normal problem. It's going to have some weird behaviors. And they're right. They're right. Let's graph this before I commit anything here. 0, negative 5, and 3 appear to be my points of interest. And notice what happens. M is greater than or equal to 3. That would look like this. Right? And M is greater than negative 5. So that would be an open circle. Now the or makes me think that this is going to be shaded away. However, notice this is also a greater than sign. That means I'm shaded this way. And I'm going to do this for a minute. Huh? That's weird. Now, if I have the or logic in between here, that means any point that is true for one of them is true for the entire compound inequality that I'm considering, okay? So 4, the number 4, is a solution of both of them. So 4 would be a solution of the compound inequality. 3 is a solution of both of them. 4 is a solution of the compound inequality. How about 0? 0 is true for this one, but false for this one. But with OR logic, it would still be a solution for me. Right? And so with OR logic, so would any of the other points all the way up to the negative 5 from the right side. And so watch this. I could rewrite this. This is the same as just everything bigger than negative 5. So I could just rewrite this instead of OR logic between these two. What's a simpler way to describe that? That's the same as just saying M is bigger than negative 5. Right? Those are all the points that are bigger than negative 5. So why would I want to use a more convoluted way to describe it? This simplifies to that. So that's kind of interesting. All right, thanks for watching. Adios.